Our next speaker is the founder of Reconnect and an engineering leader, making AI a dependable part of everyday development. He focuses on designing systems that make AI workflow stable, sensible, and tied to real outcomes. Please welcome Mandar Nilange.
Thank you, everyone, for coming in post-lunch session. So I know it's going to be, I'll ensure you guys stay awake, and there's a lot of good things to take from this session, right? So let's set the context. It's AI, right? So let's start setting with the context first. I'll be sharing my experiences. Started doing vibe coding a few months back, and then realized no, things are not really going on, right? Built something that has then stopped working, started fixing issues, and it just went into a loop, never to come out. And I said, that's not the way forward. So I did work through a different set of processes. We'll talk about that. Uh, Intentionally, I left all the models and tools out of the conversation. We'll focus on the generic process you can apply to any model, any tool that you're using, be it Cloud Code or Codex or whichever, right? Given the audience overall, having a really good time here, really happy to see a lot of builders here, and I'll just keep the business context out of it. Talk a lot more about the engineering processes and how does they help together, right? Again, CI/CD logging monitoring, that is going way too far, right, for the session. So I'll keep that out. Slide on most of the slides. If you see, there are a lot of bullet points, but I'll talk all my experiences and share. And this is going to be more of conversation starters. This is my experiences, what worked, what didn't work, what did fail, and we'll keep talking more throughout the day on this, right? About me, briefly, so outside work, I do photography, trekking, cycling. If anyone is bored with all the tech talks, we can have some different chat as well, right? While on a coffee. So key takeaways from this sessions. We've been talking about fundamentals, decade-old fundamentals. We'll just go through it. They've not changed. They're pretty much the same. And how do we apply those to engineering practices, right? Using AI as AI comes into the picture. Practical learnings from my failures, doing things. Will give examples as well as a part of it. There are a lot of anti-patterns and things to keep eye on when you're specifically looking at AI as a development assistant or agent along with working with you. And give a very, very short things. How do you get started, right? If you've not already touched anything on the AI assisted development. So yeah, I'll start with the vibe coding. I think a lot of you might have seen this news, right? Replit deleted the database. There's the extreme of getting in. There's a person who said, no, I've built it and I don't know, all my credits are out, my all costs are out, there's too much API going out and so on, right? So that's one extreme. The other extreme is going the spec kit way, right? You jot down every small thing and that brings down the agility is what I feel, okay, from my experience. So for example, if I started a spec, let's forget about the vibe coding aspects. It's useful and it's context. But if you specifically go on a spec route, right, it makes it too rigid from agile context. It's not open to change and waterfallish is what I believe. So we'll try and see what works, what worked for me, and we'll talk more about that. So things which haven't changed, right? If you look at the business expectations, I think they haven't changed fairly for decades and years. Expectations is faster time to market. No, I want something to be decided, go quicker, go before competition. I want to be done smaller team, less cost, right? Faster quality and low risk. Something goes out in production. I don't want customers to coming back and rejecting my feature because it's went in faster, right? And consistently, delivery has to continue. So that's the other expectation. Now, question is, can AI deliver all this for? So we have been structuring teams and processes around the teams. How do we do that? If we add AI into the team, can AI do that? Yes, that's with a discipline, and I'll share my experiences around that. XP principles, agile principles, 20 years old, right? Ken Beck talked about this. Fast feedback loop. You're not going to need it. Maintain a sustainable pace on your development. Keep doing continuous integrations and collective ownership. As a team, everyone owns the outcomes, right? Why didn't we do that, right? This is well known. TDD is well known. Everyone knows that's really value, but we don't do that because it takes time. We don't know how really exactly to do it, right? And the typical conversation would be, if I do TDD, I'm going to take double time because I'm going to write a code and then write the actual things and so on, right? Some places people get started on TDD and then give it up halfway, saying that no, it's done for now. So how and why this thing didn't work for longer time, right? Which is primarily a time was the main reason. Probably a bit of understanding gap in terms of what those principles are. So what happens now? AI is going to come in and help solve these issues. It will remove all the excuses that you don't have time to do the right things, be it TDD, be it getting a continuous feedback, doing smaller releases, quicker cycles, doing it on the main branch, right? The trunk based development and so on. So we'll try and see how this thing can be done, right? But before we jump on, let's probably some of this got covered in last couple of days, but I'll just revisit, right? Whatever said and done, non-deterministic is a default nature of generative AI. We can't change that. You give same input multiple times, it's going to give a different output. Limited contexts have gone to a million in some cases, but still it's 200K in a lot of cases. There's so much context that you can put in, right? And how do you effectively do it, especially if you're doing a larger scale development? How do you manage that together? Context pollution that we'll talk about, give multiple instructions back to back and it starts mixing and matching things and start hallucinating, right? So that's a bigger problem. Happy path bias, you give something about a login, build me authentication system where I can log in and register, right? In many cases, AI will go and build a login and authentication system. It will forget about the forgot password. It will not do the password validations. It will forget about the security aspects. There'll be things which probably may not be covered. And the pattern matching, again, don't reason deeply to understand, especially in case of the bug fixes. It'll not try and understand and just repeat the few things. Hallucinations, it'll confidently start saying, there's already existing API, there's existing endpoint, and so on and so forth. And of course, the first iteration is not necessarily enough. You got to keep iterating, right? I'm sure some of you and all of you would have faced some of this or all of these problems, right? And we'll go step by step as a part of these conversations. How did I go about addressing this? And the statement which I would say is, no, these are not bugs, right? These are feature of LLM. And how do you work with these features uh, to bring in the most effectiveness development that you can do as a part of AI agents? Now, this workflow, right? If you look at this is very, very standard workflow. Uh, no, new workflow is a question mark, honestly, right? I mean, you would have a coordinator, a team, or a team coordinator, or the Scrum Master who is going to get the whole list of things from requirements. There's going to be a PO, product owner / someone who is going to do a planning, all the task breakup, and then is going to go in implementation. TDD is recommended, is supposed to be done, and then validation. Somebody's going to review a PR and so on, right? Now, the key thing this process was defined is the feedback loops, right? And some of these feedback loops we'll talk about, and how do we expedite this feedback loop using AI to make it more effective. So, key quality gates and feedback loops that I've talked about, requirement decomposition, right? Now, the example that we talked about, create me a login or authentication system. That's a way too vague a system for AI not to understand. In some cases, it will go and make it a lot more complex than what you want it. It will try to build forgot password, multiple OAuth authentications, and magic link and everything. Probably you don't need that. In some cases, it will not do even what you want to expect to be done, right? And that's where these smaller releases, smaller requirement decomposition comes into picture. That's where AI can come in, and we'll see how do we do that. While working as a team, right, it's very important that you have a set of 10 tasks or 10 different things going, requirements going on, right? Person A working on this, person 2 working on this, person 3 working on this. And then you get onto a everyday stand up call and talk about what's happening, what's blocking me, where are we. It's just a shared information. So AI coming into the picture, it's equally important that it communicates and radiates the same sort of information back to the team as a whole. Test driven development definitely makes it easier because it's easier to say build authentication system and leave it there. And there's so much testing that you can do, but there are ways you could very, very specifically go and enforce and say, look at edge cases, look at the specific cases, ensure that you write a test before you write any code, right? Now, that workflow makes it a lot more efficient and confidence giving for all of us. Yes, definitely. In all this process, there's no way of keeping human out, right? You got to revalidate what tests are being generated, are those enough or not, and so on. Linting static code analysis, that's key thing. Architecture is very, very important. Leaving that to AI usually will lead to a failures because it will not understand the larger context. Probably you don't need a lot of users coming in. You don't need a largely distributed system. You don't need caching. You don't need Kafka, or probably you need all of that, right? Now that context definitely needs to come from a human who's working along with the system, and that needs to get in, as a feedback to the system, right? Process discipline, ensuring workflow is followed. That's part of the AI implementation. Second thing is testing, which is an area which can be automated, right? Nowadays, add a Chrome MCP and say, or Playwright MCP and say if it's a web or if it's a mobile, you could add a iOS simulator MCP and say, guys, no, let's go ahead and do the testing and ensure everything is good, right? So recently, anti-gravity has been doing that. If you out of box, right, you just not tell whether it's a specific task in the background, it will do everything. It will record a video and say all looks good. Now that needs to be part of the workflow. Status updates we talked about. Key important thing is having human in the loop, specifically on the architecture review and what is being generated. That's going to be the key. So in all this, as a humans, right, understanding context makes sense, right? It's a typical case. I'll keep drawing parallels between teams, right? You could take a junior team member and tell him go and develop this without understanding where it is going to be used or how many users are going to use it or the dependency where it is. That's not going to go. That's going to go multiple iterations, and nothing different with AI. So I've typically divided the context into agent.md, which is, it could claude.md or agent.md or whatever that is, right? That will primarily talk about project context, take details, and workflows. You can combine all of that together. There's some bit of work I've done because you don't want to be defining. I start to do a project one, I define a workflow. Now that workflow is really working for me, and how do you ensure that same workflow is followed in the other one, right? For example, a Python project versus the other one. So that is the area we can control. User instructions just includes everything: audio prompt, feedback, tool inputs, and so on, outputs. Model context protocol, I'm not really so much fan of it. I'll talk about it why, and why it is troublesome in some cases, but that's anyways a tool which is available, which consumes your context, right? And system instructions, which we hardly have a control over, right? Whatever tool you're using, Codex will have its own tools, and Claude Code will have its own tools, and so on, right? Gemini will have its own. So key base practices, clear task definitions. That's going to be very, very important. Smaller the tasks, very clear the tasks. It's much easier for any of the AI agent to understand and do that work. And that's where the task decomposition phase that we talked about is going to be key. Use of sub agents, I will talk briefly about that because I'll show you an example in a bit. The context really, if you add too many things, right, asking do a development, do a testing, do code review, do everything, right? At the end of the day, there are too many instructions over a period of time. If you work half an hour with that session, right, it's going to be a lot polluted even to understand what's going on. And that's going to be key. Next key thing is what I've seen myself using the old school shell scripts or any of the programming tools or programs is really going to be helpful. How we will see that, right? I'll just tell you in a brief. Some instructions: running the test for impacted areas. That's the key. And new sessions. So context is very, very limited. How do you judiciously use is going to be deciding effectively what kind of output the AI is going to give, right? So I'll give you a simple example. But the first thing I started the coding tool and said, tell me what is the context size. Okay. If you look at system prompt has taken about 2%, system tools has taken about some 7%, MCP tools is 5%. Just a Git MCP tool has taken a 5% of the context, right? That's the reason I don't like too many MCPs to be added there. And the key thing I'll come back to is the messages, right? So it's 0% on the first pass. Now, this is an example which I built Flutter app, which can take a set of medical reports, do scan automatically, derive parameters, and show all the trends and everything on it. The only thing I did on the right side, if you look at, I did say run my tests. It ran 900 cases. In 900 cases, no, this passed, this passed, this passed, this passed, and there's nothing failed. that consumed about 70K of the token window. That's straight away jumping to 35% from a 0%. And imagine if you continue to do development for 30 minutes and your workflow says that after every change you run the tests. Now, solution ideal ways that I've seen working is probably write a shell script or a sub agent and say, guys, you run the test, give me whatever failure cases and a summary of pass and fail and coverage. The main agent is just going to take that minimal information, probably 1K or 2K, and act on it, right? And that's where the context pollution will start impacting. So be careful. Atlas MCP servers, again, they keep flooding a lot of definitions. In this case, just a git added here, it has got 9K tokens, part of the context, which is probably 4.5%. And if you add like 5 or 10 git MCP servers here, you're gone. So Cloud Code is coming up with some API changes, which they say they'll do a lazy loading. They'll allow tool search and so on. It's still not live, but they announced it probably last week. That might be a help, but that's a key thing to look at. Again, memory context, it's very, very important to understand. This lot of this will overlap on a agent context, right, from the AI assisted code. There's a procedural memory which talks about what are the steps, processes that needs to be done, and workflow steps to be followed, right? That's going to be a fairly constant. You could iterate on it. Just understand the difference between what kind of memory that is being used, right? So procedural memory, your workflow is defined, is fine-tuned, it's working fine. That stays in agent.md and set of workflow files. Episodic memory is a specific iteration that you're going through. It could be a task breakdown, it could be ongoing updates and the change logs that could happen, right? So in this case, I'll give you an example. I was writing a backend service and in the same project, I had a different folder, right? And was a front end there. When I did the task breakup, right? There's a clean task breakup which talks about API, what testing to be done, everything, right? And there was a UI task breakup which said, no, build a screen, build this, and do API integration. But there was no context for the front end to understand what kind of API contract is needed. How do we handle those cases, right? And those are the cases where you got to, as a part of your workflow, ensure that any API changes that happen in the contracts, it writes to a document, MD file. And that MD file becomes a key input for your front end for integration, right? That solves a lot of problems as you go into integrations and so on. This is typically what we would do, right? Working with a team, right? Two team members working, we'll make them sit together, understand the contract, and then go on. Semantic memory plays a key role. Any architecture guidelines that you want to follow, specifically be it clean architecture, hexagonal, or whatever it is, MVVM pattern, whatever is your standard, right? Language specific standards again become very, very important. You can't keep it generic. That will always be there. Folder structure key commands make it easy for the overall LLM to understand. Some of the running tests or running lints as a part of either sub agent or a shell script can get in here as well. That will avoid the context pollution, right? And that's the right kind of memory should go right in episodic memory. If something is talking about auto-generating documentation of API, should go in episodic kind of memory. You understand that that's ever evolving. Task updates are ever evolving. Change log is again a key. From my perspective, what I've seen is I've given task 1 to 10, right? I have 10 different files to be done, which has got 20 tasks each. And I say, agent, go and do some development, right? And at the end of the day, I need to understand where the project stands after things have gone. I'll show some of the work that I've done as a part of the demo. It's a public Git repo. Feel free to take a look at it. I've built a system which I've put it publicly. If it works for you, modify if it needed, right? Requirement task definition, I think we'll try and divide, right? Typically what we need as a team working together and smoothly versus what AI needs. So from an AI perspective, it's very, very important, clear testable requirements, removes all the ambiguity, hallucinations, more cleaner, clear instructions. Small atomic tasks, you don't want to say build authentication system, right? Build an endpoint, do this, do that, do that. Task breakup, we'll see that. Up-to-date spec, API contracts, and any state assumptions, right? Which I talked about. Front end, if you have to say integrate something, and it will assume what kind of authentication endpoint it will have. instead of if you have a different one from a standard one, right, which they have learned on. So that's going to be a key here. Another thing which I've seen, right, in terms of up-to-date specs is our API, our contracts is typically LLMs have been trained at least a year or 2 year old. And if you get in and say, I want to do something, they'll pull out a package which is not latest and greatest. Okay. They'll pick up a package which is like a year old, and you will not be working on a package which is latest, and you got to keep instructing as a specific instruction going forward as a team, right, working together and maintaining auditability, what's happening on that's going to be typical requirement, test implementation, a single source of truth. If I go back and say where things are and where we are, right, be it a person doing a development or AI doing development. Task status, it's going not only in a way just to say to do and progress, it can get into blocked, whether it's waiting for review, and that's going to be a typical team conversation you would have on any agile team, right? Version documentation, I think that's going to be very very key. Change log and plan.md, which I've talked about, again part of this. So small tasks, strong tests, and up to date context, that's going to be a very important combined together to predictable AI output, right? Moving from a single agent to multi agent, right? So typically what I started when I started doing development, right, it was on a single code base, get in there and keep doing things, right? No, I want to build this, then it'll build something up. Then I realized this is not really going to work. Let me add TDD, let me add my workflow. I started adding that and then started hitting again context limitations, right? And I'm sure the guy is using Claude Code, well, compacting conversations, right? It just takes a minute or two and it's really disturbing. So that's the way I went in. And then I realized, especially on that Flutter project that we saw about, the context was like 15 minutes and that's it. It's compacting context. Then I realized my 900 test cases is generating 70K tokens, right? Which is not right. Plus any optimizations on a agent MD that I would do was very difficult to follow because it was a larger file. Let's say if I want to say TDD changes, I want to do small changes to a TDD. It was very difficult for this to understand. And that's where the multi-agent will start coming in. That where I saw it very, very useful in terms of you have a planner and you give a high level requirement. I want to build an authentication system. Now, I have a very, very specific instructions which say, how do I build, how do you go about breaking the tasks, right? Typically, initially, what LLM used to do is it'll say, I'll build backend, I'll build database layer, I'll build front end layer for everything. Now, that was not so useful for me to do any test or feel complete, right? I had to specifically instruct and say, okay, build authentication system end to end on a username password, then vertical slicing, right? Build OAuth sessions, then build magic link. Now, that's what something which I had to fine tune and which I could fine tune, right? Using a specific sort of planner instance and say, do vertical slicing always. So those are very, very specific instructions you can start giving. Same thing in terms of validation loops, be it architecture validation, be it running test, be it linting. Those are all different agents. They have very, very atomic specific tasks that they do. And it gives the opportunity to change and validate, plug and play, right? For example, today I'm running a clean architecture is what I'm doing for a backend. But at some point in time, I want to do a MVVM for UI, right? In that case, just change the architecture agent to have a different set of instructions. And that orchestration really helped. The main agent stayed in the larger context, understanding what's going on, and sub agents could go and do a specific task and return back things here. Yeah, why multi-agent? I think some of this I already talked about. Avoids the context dilution generally in terms of what you do. Each agent has a clear focused responsibility, which you can keep fine tuning, refining, changing, and it's modular, right? So you can replace the pieces there, right? Because if you're running a node, npm run test is what you do. Flutter if you're doing something else, right? So you can do a plug and play part of it. Then enables parallelism. That's another thing which I've seen, right? I mean, you could many of the providers have started supporting web development, right? You could always open a mobile waiting somewhere and say, okay, no, do task number one, just forget about it, right? Let them do it. And that helps that doing there. Role-based feedback loops, very, very clear feedback loops. This is just drawing a parallel, similarly what you do, right? You'd have a developer, a tester, a senior guy reviewing PRs versus doing a performance testing, the architect looking if things are right in place. All of this is an agent try to do things together. Skills with the complexity, even like org, as I talked about. Easy to revise if you want to do specifically on any of the roles, right? So it's much better than my learning has been much better than putting a giant prompt and say, I need a system which can take a PDF and extract all the medical reports and show me trends, right? Typically, any of the LLMs would start hallucinating, either too complicating it or too simplifying it, and there's no sense of control there. This brings in a set of sense of control in terms of what's happening. This has been there. There are a lot of agents that you could put it on a GitHub as a GitHub Actions. That's another helpful, right? If you get an issue logged in, just tag the guy, let him go, be it Jules, be it anyone, right? I think all of them support it. They can go on their own, fix things, or update documentation or whatever is needed, right? And complete task independently. So summarizing, right? I mean, non-deterministic behavior, we said, no, it's pretty much there. And how do we handle that? Ensuring that test coverage is right. That gives a lot more confidence. Context limits, the documentation system, understanding the task-specific documentations, pulling in the right instructions for a specific behavior. Context pollution is task definitions, happy path bias, right? You could instruct a TDD agent to say, ensure that you've done this, right? There could be another agent which could say, you will validate all the tests and give a summary on that. So that feedback system really works well. Put agents to their competition, each other, they do really well. Pattern matching, of course, human review architecture, there's no alternate way out there. You can always have a brainstorming with a LLM, but keep the decision with you. Ensure that gets written to a MD file or a memory, which you can pull it up and give a reference, right? Quality gates, all those quality gates did help, and all the iterations become much faster, easier. You get a lot more confidence in the code that's coming out, right? If you integrate right from TDD, validating your architecture on every commit, ensuring that all links are clear, all tests are passing, and run end-to-end test cases, right, on the actual system. But there's some anti-patterns, right? No human in loop. That's pretty close getting to a vibe coding. We still need, from my experience, I've seen, despite all those instructions and strict controls, LLM can still go a bit away, and it's good to know and keep eye on it. Uh, Undefined requirements, again, that's high level requirements, right? You put in a single line requirement that doesn't go well. Ensure the task breakup is done. I'll show some of the examples here as well towards the end. Code quality, unreviewed chunk of code, skipped test, that doesn't work. Context management, dumping everything again in a one session. AI remembers our real constraints, right? Which doesn't happen. One conversation to conversation, it'll take to forget things. And MCPs used wrongly, which we touched base upon. Definitely, look at and keep eye on what are the MCPs you're adding. Are those MCPs part of the main agent? Are they part of the required only specific on a sub agent to do a specific task, right? Because otherwise it will end up consuming the definitions itself will consuming a lot of context there. Multi-agent orchestration without guardrails, right? So there needs to be a communication between coordinator and the sub agent to come back and say whether I've completed it successfully, what needs to be acted on, if there's any action needed or not action needed, right? So if you pass it on to a test agent, and if the test agent does not come back and say your coverage target is 90%, but you're hitting 80%, these are the areas of the files which have not been covered specifically to be focused at, then things could go start getting wrong, right? And so those are the key anti-patterns that I did observe when I went about it. High risk zones, typically, leaving it to agents, definitely a security critical logic. I've seen we can have a brainstorming and rate limiting logics and so on, which really doesn't go well. Infrastructure or production environment scripts, it's typical like on a node world, right? So people would want to use Prisma and Prisma migrate and that's it, right? It just gets everything, all of your database off to whatever connection. So try and avoid that aspects because it could start deleting production things or so on, right? Financial calculations, regulatory compliances, this needs to be verified. Too high risk item to be trusted and left to an agent to do. Deterministic acceptance criteria is again pretty much similar. Ambiguous and evolving requirements, right? Unless you can't break down those tasks very clearly, You shouldn't be jumping onto an agent getting in there. Impact, I think what we do, faster delivery, that happens, accelerates your feedback cycles are quicker. TDD, which was very difficult to do, you can do it, get a lot more confidence, go a lot more faster. Your code reviews are happening, your PR reviews are happening automatically, gives a lot more confidence going faster. Reduction in rework, definitely, if you that's probably a TDD feature more than an AI feature, where you have a test-driven development, quality gets ensure the less things in the production, the cost of fixing there is much higher. Engineering consistency, again, this is more of defining a workflow which works, and that's going to be a key. Multi-agent system will definitely require a specific definition of a workflow. Test coverage, we talked about, lower operational risk, scalable requirements. You could do a probably more work with a lesser team, and clear auditability, right? You want to go back and see what happened, when, and how. Example, I think I talked about this lab testing report tracker, right? So this is very, very simple application from the today's context. I mean, you don't need application for it today, right? You could just upload a PDF document. I went for a annual checkup, got the hell lot of blood report, and I said, upload to Chat GPT and say, what's wrong with me, or it's all is well, right? And it does a good job, right? And I uploaded previous years and said, okay, now compare how things have changed. But that's a system. We built it last year. The way things are evolving is, last year it took 3 to 4 developers, probably 6 to 8 weeks to get that. And you got to give a PDF in, do a OCR, do a text extraction, then text extraction, understand if there are tables, handle those edge cases, push it out to LLM finally to do some things, come back in, and so on, right? I said, okay, let me try this system again now. And that system, it took about 6 to 8 hours, right? So I didn't spend the time in a stretch, but it was spread over a week, 1 hour a day, 2 hours a day kinds. And it took 6 to 2 hours a day, and that's the rate at which things are changing, right? And it's much more production ready. There's a link here, which you can see 900 odd test cases and a lot more confident. It has never failed me. Been trying and testing these things through. So, if you haven't started, I think the typical journey, rather, I would let me say, right? Start small, start experimenting, understanding tools, what they can do, what they cannot do. I think that's been my journey, right? I started getting in and saying, give me this system, give me that system, pretty close to a vibe coding, and then started getting into details in terms of TDD, quality gates, markdown, and then realized every new project I start, I need to redefine all of those, and there could be different things that need to be done. Make a workflow which is more repeatable, works for you, what sub agents, what scripts, and what needs to be done. And major, right? I mean, at the end of the day, as a business, the cycle times and so on, the number of bugs released to production and is the key input and feedback, right? That's where we do all of those things. Another thing I talked about, I think vibe coding, definitely good if you want to explore, do a quick prototype, have a quick discussion on the way things are going to go, right? It's much easier to go to anyone and say, instead of just having conversations in the air, you could always go back and build something and say, this is how it's going to look like, right? So it's good for experimentation, prototypes. Then there's another extreme, which is probably a enterprise way of working. All those guys believe in scaling, agile, safe, and all that stuff, which I don't believe in. But that's where you define all the detailed requirements, and somebody approves it, and it just keeps doing those things. There's a golden mean which I like from my perspective. Right, I do have a high level specification what I want to achieve, but let agent plan things in a plan mode, and they do a better job, especially in a smaller context where you're not very, very tying it to do exactly the way it has to be done or identified in the first go. You could have a conversations in a plan mode and challenge and saying that, are there better ways to do this? I want this to be performant. I want this to be caching and so on. And it'll iterate very quickly there than frozen spec, which is generated on a day zero, right? So briefly summary, and after summary, I'll show quickly GitHub repo, right? So fundamentals, I think decade-old fundamentals haven't changed. No, it's just AI coming in is going to help us do them effectively, be it TDD, agile, small loops, doing vertical slicing, trunk-based development, CI/CD, everything stays. It's just the quicker clarity, ability to do it faster, removes the friction, and again, use the right mode based on the context, which way you want to go. Workflow that works, again, I have a workflow which works for me. It's not necessarily workflow that is going to work for you, or a specific use case that you need to really look at and do that. Start small, measure impact, iterate, discipline. I think that's going to be the part of it. And it's not a magic, right? At the end of the day, you engineer for this coding agents and coding assistants to be helpful. So I'll briefly probably share this GitHub repo at some point in time. And another challenge which I came across was the typical scene, right? I mean, you want to really want to do a development, and the cloud provider comes and says, "Yeah, that's it. You've hit the 5 hour window." And come back after 5 hours, right? That's initially after first hour of working through it, and that started putting constraint on me. What I wanted to do, I said that's not going to work, and that's the reason I started with this small project, which is a workflow independent of any of the tools, right? It doesn't matter. So that was the one reason. It was putting a lot of constraints on the time window. Second, every 2 months there's a new model which really does better, and I don't want to stuck to a system forever, any system. So that's two key drivers, which included building this project, which again briefly talks about what all it does, and I'll take a quick thing in terms of the how the workflow goes about it. Right, first you start implement a user authentication endpoint. It will identify the intent coordinator. It will route it to a specific sub agent which is meant to a feature development, right? And we'll look at some of these files as well in a minute. If you see the first step is identifying the intent. Second is exploration and planning, right? Which is explicit state I've added to say, look at the code base, understand the patterns which are there, understand existing functionality which is already there, and make a plan, right? Don't assume it's a greenfield project and start planning, right? TDD, typical red, green, refactor stage, and commit sort of validations. So do have some examples here. Did try with few tools, Stress, Cloud, and so on. Okay, workflow files, playbooks. I'll just show some of them. Yeah, coordinator probably. There's a set of reporting guidelines, announce the workflow start, detect the intent, right, and so on. It's a very, very clear workflow for orchestrator. If you go to a TDD, all is going to talk about the specific TDD cycle that needs to be done. Now, if I want to do fine tuning any of the TDD aspects, I can do this. Part of the system, which is probably a same thing, I have an overall status of the project where it is. It talks about total feature completed 4. It just talks about some of the examples, right? What is recently completed, what is blocked, what is my test coverage, right? There's a good report for any team to see, and some of the changes which are listed here. In case of specific feature file, it goes more detailed. What are the different tasks which are being completed? It talks about what are the commits which are being done. Talks about the files we changed, right? Now, this is a good input for as a team for us to understand what's going on. So that's the workflow which is built in. I've tried to keep it generic, works for me. Feel free to make it yours if you want to add anything. The few feedback came in, it doesn't work on Windows because it's all shell scripting to install it. So maybe if somebody knows PowerShell, probably can jump in and relook at it. So that's pretty much, I think, I wanted to cover part of this. All right. Thank you. Thank you, everyone. Really pleasure to be here.